All right, hello class. Hope everyone's doing well. I hope y'all are staying safe and your families are having a happy Easter. I hope y'all are like barbecuing and having a good time, with family and whatnot. Um, I'm making some ribs myself, some fajitas, and some mashed potatoes, some corn. I'm gonna fill myself up pretty good. Um, let's see. So what I want to do here is I want to get to um, the next subject that we're doing here, which is going to be acids and bases. I'll be doing a couple of these videos, and we're going to see how this turns out. Okay, um, we're going to go with part one here, and we're just going to do acids for right now, and then I'm going to try to put this on a video on YouTube, put that into Nearpod, create some questions for you to answer, and then we'll move on to bases, and I'll do the same thing with the bases. Okay, so here we go. First part here is going to be the acids. Okay. All right. So acids are going to have a pH from 0 to 7. They're going to be electrolytes. Okay, which means an electric light just means that something that can conduct electricity. I think you've seen some of these um, experiments where they connect a wire to a lemon, and then the lemon is connected to like a light bulb, and then it turns on because it conducts a little charge. Okay, so just remember that electrolytes, acids are electrolytes, which means they conduct a current. Okay, they're also sour, as you know this. Um, Getting some lime or eating some lime or lemon, it tastes pretty sour. What you need to know here is that there's an excess of hydrogen ions in a solution when it comes to acids. Okay, that means that there's a good amount of hydrogen ions inside the solution, making it acidic. You need to know also that um, hydrogen donates protons when it's in a chemical reaction with something. It's going to donate its ion to the base, and on the other side, you would have um, its conjugate base. All right. Let's see here. They react with metals. Okay, yeah, they react with metals to make hydrogen gas. We've done this before. Whenever we've had let's see, hydrochloric acid mixed with zinc. You've done this before. It created bubbles. It created gas. It created heat on the bottom of that test tube, and then we've captured that gas and you've made it pop with fire. So that's what it means that that acids can react with metals to create hydrogen gas. All right, moving on here. So some of the examples of acids are going to be stuff like vinegar or milk. Milk is actually acidic, believe it or not. Sodas for sure, and then of course citrus. Uh, oranges, limes, lemons. All these are examples of acids which have a pH between 0 and 7. So we get to something that is called an Arrhenius acid. That's going to be a chemical compound that increases the concentration of hydrogen ions in an aqueous solution. So let's say that I have something like I don't know, like I crushed up some Tums, which is a base. It's going to be an antacid. Okay, if I crushed up some of that and I made a solution out of it, that solution will become very basic. It'll have a pH between 7 and 14. Now, remember, acids have a pH between 0 and 7. So if I poured an acidic solution inside the solution of crushed up Tums, I can make that solution more acidic if I pour more hydrogen ions into it. Okay. And so that's going to be considered an Arrhenius acid, something that can increase the concentration of hydrogen ions. So this is going to be a chemical equation here. This is hydrochloric acid, water. This is hydronium, and then we have a chloride ion here. All right. So in aqueous solutions, acids form a hydronium. What's happening here is that this hydrogen from the hydrochloric acid is going to be after the reaction, it's gonna donate itself to the base, which is going to be this water molecule, and so on the other side of this reaction, we have this hydronium ion, okay? Um, and then we have this chloride ion, all right? So hydronium is going to be H3O. In this situation here, the Arrhenius acid is going to be the hydrochloric acid. Bronson and Lowry acids, this means that the protons of the hydrogen ion are going to be donors, just like it says here. It says hydrogen, the hydrochloric acid, is going to donate its hydrogen to the water molecule, and then and on the other side of here it's going to be the chloride ion and the hydronium ion. So when we look at the acid, we know that we are going to create a conjugate base on the other side of the arrow, okay, which is the product side of the reaction. Whenever we have a base, which is the water that you see here, um, it's going to form a conjugate acid on the other side of the arrow. All right, which means that a hydrogen is being added to the water, so it creates the hydronium ion. All right, so here's some examples here. Okay, just give me a second. Sorry, I'm playing with this because I've never done this before. All right, so as you can see here, um, this is the the HF. Okay, this is going to be, so it says give the conjugate base for each of the following acids. The HF here is going to be the acid. Now, if we take a hydrogen away, it just becomes the fluoride ion by itself. Okay, so this would be considered its conjugate base. If we have H3PO4 here, all right, this is going to be the acid. We take one hydrogen away from it, and it's going to create its conjugate base. Okay, so the H2PO4. Same thing here. Here's the hydronium ion here. Okay, so you have H3O, but if we take a hydrogen away from this molecule, it creates its conjugate base, which is H2O. Polyprotic just means it's an acid with more than one hydrogen. Okay, that's all that means there. All right, so let's see here. In chemistry, hydronium is a common name for the cation H3O derived from adding a proton. So remember, all that's happening here is that we have hydrochloric acid like this here. Uh, it's going to donate its hydrogen onto the water molecule and thus creating hydronium. Okay. All right, so we're gonna stop it right here, and we're gonna I'm gonna give you some questions